Ciao everyone. I'm Federico, and this is a joint work with Nicolo, Tom, Roberto, and Stefano that featured that stock last week. Okay, let's see. So no LLM, sorry. Okay, so what our work started from the consideration that the online advertising market in many applications is shifting from second to first price auction. So as we saw in the first talk, since all this bidding is automated, this poses a technical challenge. Okay, so what do? We study repeated first price auction in the online learning framework. Meaning that we don't have like a bunch of data and we make one decision, but we do decision online. And we take the perspective of the bidder. So we're not the platform, we are the bidder, and we want to maximize our happiness. Great. And so first price auction has been studied a lot in online learning, but we make two tweaks. The first one is that we do not assume a priori that the bidder knows the valuation of the item that is bidding for. And this kind of makes sense because maybe like, you want to buy an ad slot, but you have not a clear idea how much winning this ad slot will give you. And second, we also want to understand what is the impact of like the policies in terms of transparency that the platform can take. Okay, so these are like the 2 points. Let's see. This is the model. It's pretty simple. So we have a big T interaction, one after the other. At each of these interaction or time step, there is an adversary, the nature, that privately generates 2 numbers. VT, that is the value of the bidder for the item, and MT, that is the competition. Okay, and what the learner/bidder does is to post a bid without knowing VT. Okay, this is critical. And then a first price auction takes place. This is the utility of the bidder. So if it wins, so if BT is greater or equal than MT, then it gets its utility. That is like the value minus the bid it pays. Okay, and the bidder receives some feedback. Okay, and the goal is to minimize the regret with respect to some benchmark. We're doing online learning, so it's the best fixed bid in hindsight. Okay, so this is the problem. Let's see, and these are our results. So big table, let's try to parse it a bit. So on the column, we have like the data generation model. So how we assume that the data are generated. And on the rows, like the feedback models that we study. And I mean, super quickly here, the full feedback is like a benchmark, like at the end of each auction, everything is revealed. While in all the other settings, the evaluation is only discovered if you actually win the auction. And then like given what kind of information the platform discloses at the end of each auction, we studied 3 different type of policy. So transparent, semi-transparent, and bandit. And for example, in the semi-transparent feedback, what happens is that the platform only reveals the winning bid so that you know how much you should have bid in order to win. And we fully characterize all the minimax regret regimes that you can achieve in that model. And we have these 3 colors. Okay, so great. Thank you.